Hey guys, how you doing? This is Guy here. Welcome to this live on Sunday, March 23rd. It's my pleasure to always bring you in my lab. We study together, we grow together. Today we're going to talk about DHCP Relay, as you saw in the title. I'm going to spend some time inside Packet Tracer to show you or to explain to you how DHCP Relay works. And this is actually because I received a question in my course on the CCNA 200-301. I received a question from a student. Actually, the question was in French. This is the question itself in French. I just finished the English version of the explanation. Now I'm just doing the same thing in I just finished the French version of it. Now I'm going to do the same thing in English just to explain DHCP Relay and then show you how to do that inside of Packet Tracer. So basically the question is asking, or the person or the student is asking how they can implement a DHCP server inside an environment with 9 VLAN. They gave an example with 9 VLAN, but in our case, we're going to keep it small and simple. We will do 2 VLANs, including or not including the native VLAN or the default VLAN. So we're going to have 3 VLANs in our environment, and I'm going to show you how inside of Packet Tracer you can configure DHCP Relay. This is a very important topic because DHCP relays are used everywhere. Like if you have a wide or huge enterprise deployment and you want to centralize your IP management, you need to have a single or few DHCP servers for all your sites, for all your users. And from there, you can see the leases and everything that pertains to DHCP. So that's why you need to know how to configure relays, or you configure your firewalls or your routers to be DHCP relay agents, and they're going to forward the UDP broadcast to your DHCP servers. That's what we're going to see today. Before that, a little bit of housekeeping. I was live yesterday with the students, the ones that are taking the CCNA 200-301 training. It was a really good conversation. So now we'll be doing meetings every 2 weeks. So we are meeting on Saturdays. It was 12 p.m. my time here in Denver, Mountain Time. And that was a good experience. So if you're studying for the CCNA 200-301, I have a course on KBTrainings.com. It's actually en.kbtrainings.com for the English version, because I do it in French as well. In that course, you're going to have access to about 150 videos, very well done, very well explained. And you also have access to me. Every 2 weeks, I come live on Sunday for about an hour or even more. Last time in French, we did almost 3 hours on a Saturday. So I'm there to chat with you, to connect, to go beyond the training, to talk about our experiences, job search, all kind of good stuff. So if that's what you're looking for, make sure you join me there. Forgot to tune on my other angle over there. So yeah, let's get that started. What else? If you don't know me, if you go discover me for the first time, make sure you follow me on social media. I am at Gibisuku or KBTrainings. Gibisuku is personal. KBTrainings is for the platform here where I share with you my knowledge. And I am a professional in cybersecurity, and I do labs most of the time. So what I do is just I put a camera there, I bring you in, and we work together. Hope everything is good. Say hi in the chat if you're watching us live right now. Let me just make sure. Adama on Facebook. Yep, we have a couple. On YouTube. We have a couple of people on YouTube. I'm also live on Facebook as well. So let's get started. First of all, I'm going to explain DHCP in general. Because, here I go from zero to engineer. So my goal is to pretend. Neville is live. Good to see you, Neville. Hi, Sean Woods. Thank you so much for your presence in the chat. So before we go deep into the lab itself, I'm going to explain a little bit DHCP, what it is, and how it helps you in your network. Some of you know it, some others don't. So I'm here for you. And then after that, I'm going to explain DHCP Relay, and we'll go from there. Let me close this and put this in full screen. So DHCP, I think I should probably just do a black screen. It's probably better. Let's do this. Oh no, it's coming up on a different screen. Never mind. So DHCP, what is it exactly? If we have a network, let's say you have a switch where, of course, we have our router or firewall going out to the internet. So if we have a switch and we have a couple of computers connected to this switch, for the computer to to communicate between themselves or to go out to the internet, they need to have IP addresses. And we all know what an IP address is. So what you can do as a network administrator, you can go on each computer, give it an IP, because each network has its ID. For example, in our case, the network is 10.0.0.0/24. And of course, this is probably .1 because it's the default gateway. And then we need to have IPs on these devices here. So what happened is that you can go manually on each workstation and configure your IP addresses. Or what you can also do is that you can enable DHCP, which means Dynamic Host Configuration Protocol. It's a protocol that you can use in a network or a service that uses this protocol. You can enable this service inside your network to make sure that every new computer that connects to the network will have an IP address assigned to it automatically. So if you have 1,000 of users, you don't have to go on each workstation to configure an IP address. And what you need to configure is not only the IP address. You have a bunch of information that you need to configure. Beside the IP, of course, you need to give it the subnet mask. You need to give it a default gateway. You need to give it a DNS server. You need to give it a bunch of things. You can configure TFTP. You can configure all kind of information that your workstation needs to work properly. All of this, you can automate the assignment of this information with DHCP. That's good. It works. You can run it anywhere. You can run it on your router. Like in my case here, I can run my DHCP server on the router, or the router can be my local DHCP server, or I can have another dedicated device. Let's say, for example, I can have a Windows Server 2025 doing DHCP. It can also do many other things. I can do DHCP on it. I can do DNS, Active Directory, or whatever inside my local network here. And how does DHCP work? Just the regular DHCP inside a local area network. The way it works is that when a computer joins the network, if it's configured to get its IP automatically, which most of them do, because when you have a computer you want to connect to a network, you don't know what that network is. So it's very rare to find computers with statically assigned IP addresses. Most of them are wide open, waiting for a new IP coming from the DHCP server. So when a computer connects to the network, what it does first is that it sends the broadcast to get an IP. And that broadcast is called a discovery broadcast. The actual process is called DORA. This is just my way of kind of memorizing the process. DORA. So the first action that happens is D, the discovery. And this is actually a very popular question that you may get on an IT interview. Let's say you're going for a network technician or maybe a network engineer sometime. They can ask you to explain the DHCP process. How does a new computer get an IP inside a network? So first of all, the first thing that happens is that the computer is going to send a UDP broadcast, which is called a discovery. So the broadcast is sent to all the computers in this broadcast domain. And I'm pretty sure you know what the difference between a broadcast domain and a collision domain. The broadcast domain is the area where any broadcast can reach. So in our case here, if we need an IP for this computer, it's going to send a broadcast to all this network. So this other computer, the switch, the router, and even the Windows server, they are all going to receive the broadcast because it's sent to anybody. It's not a unicast, it's a broadcast. This thing is kind of annoying. Let me push it over here. So like I said, first process, it's the broadcast being sent. And by the way, all of this is very well explained in the CCNA training on KBTrainings.com. And I have more trainings coming on Cisco Meraki. Actually, I just bought some licenses for my MX3 or MX64 that I have. So a couple of trainings on Meraki, Fortinet as well, and much more. So make sure you go there on the website. Even if you don't see something that you need now, make sure you are in the newsletter. So when I have some new cool video, you'll be informed. So there's a broadcast that goes out to request for an IP. The broadcast is sent. We have two ports with DHCP. There's the port 67 and port 68. I'm not sure which one is which. I don't really care, but I just know that one is for the server, the other one is for the client. I think the 7 is for the server, something like that. We're going to see it in Packet Tracer if you need a clear answer on that. So it's sent to the port, let's say 67 for now. So when it's sent to the port 67, everybody's going to receive the broadcast, but only the device running DHCP server on it will listen to the port 67, and it will know that somebody needs an IP address. I need to provide an IP. What's going to happen? Then we have what's called an offer. This is the O in the DORA. So the offer will be sent from the DHCP server to the computer that requested an IP address. So the offer is a unicast. So it's sent specifically to that device. And then when the device received the offer, and if he likes it, which is usually the case, but if, for example, it had another offer from a different device or something like that, it can decline the offer. But if the device wants to receive the IP, it's going to send a request. This is the R. The request is now a unicast sent directly to the DHCP server. And then when the DHCP receives that, it's going to send an acknowledgement. The acknowledgement is like, okay, you keep that IP. This is the IP you have now in the network. You can now talk to everybody else inside our network. So if you notice here, we used two types of connections of traffic. We used broadcast first, and then we use a unicast. So now the problem happens when you have a big network. Let's say you have a network with a bunch of VLANs, or you have a huge deployment with, let's say, for example, you have an HQ with your router and all your devices inside, and then you have a branch number 1, for example. And then you have a router and many other devices over there. So what if you want to use a single DHCP server that is hosted at the HQ or inside a data center? So you want that DHCP server to be giving IPs to the devices in the branch. The problem is because now the HQ is in a different broadcast domain, your broadcast from your device will not be able to get to the DHCP server. That's why you need to use a DHCP CP relay. A DHCP relay is this mechanism where you use an agent. Most of the time, the agent is your main firewall or your main router. The agent will now forward the broadcast for DHCP from its network to wherever the DHCP server is. It can be anywhere. It can be in the cloud. It can be sitting in a data center somewhere. Now your relay agent is going to send that broadcast, but now it's not a broadcast anymore, because when it comes inside, it's a broadcast. It's going to be transformed into a unicast, and then you're going to send it to the DHCP server. The server is going to respond, and then the agent is going to deliver the IP address to the device that needed it. So that's how it works. That's what we're going to do in the lab today. I'm going to show you the commands on the Cisco iOS, how to make your router a DHCP relay agent. And that's using the command IP helper address. So we're going to see that really soon. Like I said, the CCNA or everything you're studying for, like this notion specifically, is everywhere. It's not only for the CCNA. It's for all the devices, all kind of network deployment. So if you find yourself in that situation, you know that DHCP helper can help you, and you will be able to use that. In here, I'm showing you an example of my local 40 gate. Here you can see that on the DHCP, currently it's set to, let's see, it's currently set to regular DHCP. And if you go on the advanced, you can see that it's in mode server. So you have two modes here. You can either be in mode server, where the device will receive an IP on a request. It's going to respond. It's actually acting as a DHCP server for my local network. Or I can put it in relay mode, which will make my device forward the packet to an IP that I can specify in this field here. It can be a public IP out in Azure, for example, or it can be a private IP sitting in my data center that goes through an IPsec tunnel. All of that will help you. Okay, I see Sean says that 67 is for the server, 68 is for the client. That is true. Thank you, Sean Woods. So those are the ports for DHCP. So this is my 40 gate. As you can see, I can set it as a server or as a relay. Then it's going to be an agent. But now, let's jump in Packet Tracer, and I'm going to show you how we can get that network set up and play with DHCP Relay. What I'm going to do is bring a router in my topology, and I'm going to bring a switch as well. And then I'm going to add a few workstations. I'm going to have 3 of them, one for each of the VLANs. 1, 2, 3. And then I'm going to add a server as well, because the DHCP service will be running on this server. And we don't need internet over here. I think everything is fine. Let me zoom in a little bit. Okay. So let me connect all these different cables. All the different devices. So first we go from the switch to the router. We go from the switch to the server, switch to the device number 1, number 2, and number 3. Let me write down some details for this network. This is going to be, we're going to have 3 VLANs. The default VLAN, let me write it somewhere here. The default VLAN, or the VLAN number 1, will be the network 10.0.0.0/24. I hope you can see this. Let me push this. All right, so this is the default VLAN. And then we are going to have, no, I want to modify this same one here. And then we're going to have the VLAN number 10. It can be finance VLAN, for example. And this is going to be 10.10.0.0/24. And then we're going to have the VLAN number 20, which is, let's say, the IT VLAN. Here it's a dash, and then it's going to be 10.20.0.0/24. All right. So in our deployment, we're going to have this router will be the default gateway for all the VLANs. We won't do any routing at the switch level. All routing will be on the router. So it's going to be router on a stick type of design. So this is going to be, if we stay in the default VLAN, this is going to be VLAN number 10.0.0. Device number 10.0.0.1 for the router. And then the server will be 10.0.0.2. All these other devices can have their own IPs that they will get from the DHCP server. So that's good. Actually, I can change the name and call this DHCP server. All right. So what else we can do here? Like I said, we have 3 VLANs. Let me explain a little bit what we see right now. This will be in the VLAN number 1, the default VLAN. This will be in VLAN number 10, and this will be in VLAN number 20. The server will stay in the VLAN number 1, and the device or the router will be routing the traffic between VLANs, which means that we're going to create some sub interfaces. We're going to have a sub interface for a VLAN for the VLAN 10, another sub-interface for the VLAN 20. Here in the switch, we need to create these VLANs as well. We're going to create the VLAN 10 and the VLAN 20. So the goal is that when the server is configured for DHCP, this computer should be able to go out in the same network, grab an IP. The server will also be ready to deliver IPs for the VLAN 10. So we're going to create a new pool inside the server for the VLAN 10. But because the server is going to be in a different network, we are going to configure a DHCP agent here locally on the router, on the subnet, on these two sub interfaces for the 10 and the 20, and it's going to be forwarding the packet to the server, and that's how it works. Oh, by the way, I think it's actually gonna be more fun if we add some sniffers over here. Sniffers are good to see the kind of packets that you see that you're routing in your network. Let me put this server right there. Let's delete this this link, and because I like to see things how they work, so we are going to grab a sniffer. I'm going to use two sniffers because a sniffer can only show you one direction of traffic. So I want to see bidirectional traffic here. So I'm going to use two sniffers. Let me grab the cable. Okay. So we are now connected to our server again. So now we need to do some quick configurations on the, let's start with the switch. I'm going to open the switch and go under CLI. And this is the switch CLI. Let me make it a little bigger. And also I think it's too close. Let me reduce this size a little bit. A little bit more. All right, this is the switch. I hope you can see it well now. All right, so what we have to do here is primarily just create those two VLANs and assign the two ports in the VLAN. Let's see if we have the, okay, we can see, so fast Ethernet 04 and 05 are respectively in VLAN 10 and VLAN 20. So we're going to do, we go under the config mode, we go under the interface, oh no, let's create the VLANs first. So first will be VLAN 10, name will be finance, and then we're gonna do VLAN 20, name. Now if we do show VLAN brief, we can see that we have our two VLANs, finance and IT. They don't have any ports in them yet. That's what we can do now. Let's go under config mode and go under the interface fast Ethernet 04, do switch mode access, and then switch mode access, oh no, switch access VLAN 10 for the 4. Then I'm gonna go in the 5 and assign the VLAN 20 to the port number 5. Okay, so now if I do show VLAN brief, now we have the port number 4 in the VLAN 10 and the port fast Ethernet number 5 in the VLAN 20. That's good. So that's simple. What I just did is that I changed the configuration on these two ports here to put them in different VLANs. And in the meantime, you know that the fast Ethernet 03 and all the other ports are part of the VLAN number 1, that is the default VLAN. Another thing I need to do is that this fast Ethernet 01 needs to be a trunk. So to do that, I need to go inside the switch again. Let's go in the switch and make sure that I have configure terminal interface fast Ethernet 01 switch port mode trunk. So this is a trunk. I'm gonna say and. That's all we need for now. So the switch is good to go. Let's go in the router. Inside the router, Let me make this one a little bigger. So inside the router, I don't want to go through the wizard. I'll just say no here, and that's it. Okay, let's go in the privilege mode, configure terminal. We need, first of all, to we need to put an IP on the gigabit 000. So I'm going to do, I hope you can see this well. I don't know if I need to zoom in a little more, but should be okay. All right, so inside here, let's do interface gigabit 000, IP address 10.0.0.1/24, no shut. And if we look at the device, I mean at the topology now, it's green, and this one is coming up. The spanning tree is working. So that is for the first interface. So now we need to create sub-interfaces for our other VLANs that we have. And this is just router on a stick. You should probably seen this before. If not, you need to learn some networking on my course that is on KBTrainings.com. I go really deep and people seem to like it. It's really good. All right, so for the sub-interfaces, we need to create one for the VLAN 10, another one for the VLAN 20. So what we're gonna do is we're going to go just right here. We can do gigabit interface gigabit 000.10. That brings us into the first sub interface. The first thing we have to do is determine the encapsulation. It's going to be .1q for the VLAN number 10. And this is just a way to identify the sub interface. We can have as many as possible. I don't even know how many, what is the maximum value. But this is now the tag on our VLAN. So this is for the VLAN number 10. These two numbers don't have to match. You can, I could have put 1 here or 2 or whatever, but for consistency and ease of management, I just put the same as the tag of the VLAN. And then I need to give it an IP address 10.10.0.1/24. That's it. And then I can do another one for the number 20 or the VLAN 20. Same thing, encapsulation. I'm just going to do 20 and then give it an IP. Here it's going to be 20. All right, we have our sub interfaces created and configured. So I can do show IP interface brief. This will show me that I have my 3 interfaces correctly configured. So the next thing I have to do is now configure the router, this server. But before going there, let's configure the sniffers. And sniffers, if you're not familiar with them, they'll just show you the flow of packets as seen in the wire or on the wire. And because you can only do one direction, that's why I have 2 of them. This first one will be watching or will show me the traffic going from the switch to the server. This second one will show me the traffic from the server to the switch. That's why I have these 2 here. So let's now go on inside this first sniffer. Just make sure that the port that goes to the switch is the ether 0. So that's the port 0. So I'm going to enable it on the port 0. And I can filter out all these other noise like spanning tree, DTP, and all these other things. So let me go under filter and I'm going to go in miscellaneous, filter out DTP, spanning tree, CDP, VTP. VTP wasn't even there. And then I'm going to clear this screen so it's now empty. The buffer, the capture itself, it's empty. And we are on port number 0. That's good. So we go inside the second sniffer. This one we need to listen to the port number 1. So we go on the GUI, we select the port number 1, and we do the same thing. We filter out some noise like DTP, like spanning tree, like CDP, and VTP. Okay. So I can also clear this screen so we have a fresh capture. So now let's go ahead and configure our server. For the server, and I love this server, by the way. Packet Tracer has gone a long way. Right now, there's a lot we can do inside a server like this. Some of that has been there before, but I just discovered that you can also do some programming as well. You can write some Python code and some kind of cool stuff. So it's really good. I haven't really used it for any kind of automation or something, but I think I will try to use Packet Tracer for that. For now, I use CML for all kind of advanced stuff. But Packet Tracer is really good for the CCNA, even though you can still go a little beyond, but Packet Tracer, you have everything you need there. So if you come here inside the server, let me make it, okay, actually you can see everything from here. Let's just go under configuration. I'll go under fast Ethernet, and I'm going to give it a static IP because this is a big server in our deployment. We don't want to give it dynamic IP. It's actually better to give it a static IP instead. So I'm going to do, this is going to be 10.0.0.2/24. And some other details we may need are the default gateway. It's 10.0.0.1. Maybe the DHCP. I can be my own DHCP. I can do 10.0.0.2 or I can do 127.0.0.1. That works as well. So that is for the IP configuration for the server. Next, I need to enable DHCP service. I need to go under services here and then select DHCP. As you can see, you can do a lot with this. You can do HTTP, HTTPS, all kind of stuff, even TFTP. But for now, we are just going to do DHCP. Now it's off. I'm going to turn it on. And then we have the server pool. This is the first pool that is by default there for this interface here. I can add more pools for other VLANs. We're going to do that later. So now let's just give it the details for the default gateway. It's going to be 10.0.0.1. DNS is going to be 10.0.0.2, myself. The IP will go from 10 to whatever. And then the subnet mask is there. I can just do save. As you can see, now we have the details configured for our pool for the VLAN 1. So this is going to be the default pool for the VLAN number 1. And how will the servers know that? It will depend on what device is sending the packet. If it's coming from our local internal network, we are going to give it the IP from this pool here. If it's coming from a different device, then it's going to be treated differently. Now we need to add more pools. Let me go and add one for the VLAN number 10. So I'm going to call it VLAN 10. And the details will be slightly different. We're going to have 10 here. DNS will stay the same. The IP will start from 10. And then that's it. I can just do save. No, wait. Oh, no, I meant to say add. Okay, it's supposed to be add. So we have now VLAN 10 being added. 10.0.0.1. All right, that's good. We start from 10 as well. So let's do the same thing for 20. We're going to do VLAN 20. It's going to be 20 here, 20 there, and then I can do add. So now we have pools for the VLAN 10 and the VLAN 20 along with the default VLAN. So what I'm going to do now is go in one of my workstations and try to get an IP dynamically. And because we're doing that, I would like to push this on the side like this. And I'm going to bring up my sniffers. I'll click this button here so it stays on top. It doesn't go away. And then I'm going to bring up the second one as well. It's also gonna stay on top. So we have our sniffers. One second. I think I need to start with this first. Or do this and then put that there. As you can see right now, we have ARP going back and forth. It's actually going from the server going down because it's trying to ask, I think, the default gateway. If you want to dig into here and open the packet and see what's inside, you can see some more details. But for now, let's focus on our DHCP. So I'm going to open this workstation here in the corner. It's right here. I'm going to go under config, or yeah, let's stay on the config. I can go here, fast Ethernet 0, and I'm going to select DHCP. So once I do DHCP, we should see, look over here, we should see DHCP packet being sent here. The DORA that I mentioned, it's gonna happen somewhere over there. So once I go in and I do DHCP, okay, I think you were able to see 4 DHCP packets. The first one is, let's go into it a little bit just to give you some more details. Which one is this? This is from the server. Let's start with the one from the switch. This is from the switch. So from the switch, the first thing that we see is a DHCP discovery. As you can see, this is source is coming from 00. Destination is everything. So this is the broadcast. Destination is the broadcast, and it's going to be sent throughout the network. As you can see, the source is port 67. This is the client, just like Sean said in the chat. And the destination is the port 67. This is the server destination port. And then after that, we have an offer coming from our server. If you look inside the offer, it has its source in it. It also has a a destination set to a broadcast. But if you look at the MAC address, the MAC address will be the MAC address of the device that requested the IP. We have the port and a lot of stuff there. But if you look at the offer, you can see the offer is there. Oh, I'm sorry, you can't see that. Let's bring it down here. This is the offer. Your client is 10.0.0.10. This is the offer that is being given to our device. And so on. So what's going to happen? The device is going to accept, and then now it has an IP. Look here, it has 10.0.0.10 as an IP address on it. That's good. But now let's come here and clear these sniffers. Second sniffer, I need to clear that. So if we come back here, if we do the same thing for the PC number 1, let's just try it. It's not going to go anywhere because there's no DHCP server. If I come here and I go under fast Ethernet and go under DHCP, nothing is happening over here because the packets do not get sent to the DHCP server. And what do you get? You get an APIPA or an automatic assigned, whatever. Is it the automatic IP? Something like that. So it's 169.254.208.190. This is showing you that the DHCP server is not responding. It's not up or running. So what you want to do now is configure our router to be a DHCP relay agent. So to do that, we need to open the router. Let me push these on the side a little bit. So now inside the router, let's go ahead and configure our agent with these few commands. Configure terminal. We need to configure that in the 2 sub interfaces that need to relay the DHCP. The main interface doesn't need to do anything because everything is running locally. The server is local. We don't need IP helper on the main interface, but the 2 sub interfaces, we need to configure them. So the first one will be interface gig 000.10. We're going to say IP helper address. Where are we going to send the packet? To 10.0.0.2. This is the DHCP server. By the way, let me just make sure I move this one to static. I don't want to keep this because I want us to see the packets when it happens. Let's go back to the router. And then we do enter. We'll go inside the interface 000.20, same command, enter, and then end. You can add some more details, like if you want to trust some sources or not, you can do like IP, DHCP Relay, info, trust all if you want to trust all packets and stuff. But that's going a little more into a little more details. But let's close this one. So we're done with the router. Now let's pull up our sniffers again. So now, if I do the same thing, observe the two sniffers. So now if I go to the computer number 1 here and then do DHCP, look, there's ARP that's happening. And then we should have DHCP packets being sent. Let's give it a moment. Actually, because the ARP failed, it didn't respond, but I think it's gonna launch a second request. Or if we do it the second time, because this is the first time it's talking. Let's go back to static again and DHCP. Okay. All right. So now we can see this DHCP packet being forwarded from the router all the way to the DHCP server. And if we go into them, let's see which one is coming from the switch is the sniffer number 0. So let's go to the number 0. Look at this first one. The first one is the discover, but look at the source. The source is actually the IP of our sub interface, because the sub interface is the DHCP relay agent. So now it's sending the packet to the DHCP server requesting for an address, an IP address. And then after that, what happens? After that, we have the server responding with an offer. How do we know this is an offer? Look at this. Inside it says, look, your client should have 10.10.0.10. That is the offer that is sent to our client. And then you have the request and then the acknowledgement. So bottom line is, if we come now to this device, it now has an IP address that belongs to its VLAN. It's 10.10.0.10. Same thing if you go to the PC number 2, you can do the same thing, config fast Ethernet. Let's do DHCP. Give it a moment. As you can see, we now have 10.20.0.10. And from here, we can do anything. Let's see if we can ping. We can ping 10.20.0.1. We are able to ping the default gateway without any problem. And that was the main thing to do or to accomplish in this lab. So let's say you have, for example, your DHCP server in a data center and you have an IPsec tunnel to the data center. Your firewall will be the DHCP relay agent forwarding the DHCP request to through the tunnel all the way to the data center for the data center to respond. That's all, guys. I think I've covered everything that I prepared for you. If you have any questions, you can leave it in the chat, or you can leave it in the comments if you're watching this after I was live. And you can also follow me on social media. Make sure you like and subscribe the video so you don't miss any of my future lives. And thank you for everybody that is in the chat right now that said a word. Patrick, thank you. Adriel, thank you. Reynold, Rosario, hi. Thank you, MJ Digital Careers. It's been a pleasure, and I think that's all for today. We are going to see each other either sometime during the week or next Sunday for another new lab, or maybe we're going to talk about something else. I think next Sunday I'll probably talk about career or any other thing that is not technical. Nice nugget. Thank you, Sean. It was good having you live. Thank you, guys, and I'll see you in the next one. Take care and bye.